What's up, Algebra 2? We're going to get started on the homework here. Again, trying to make sure that we're staying with all the things we've talked about. We've talked about complex numbers. We've talked about the discriminant and factoring and quadratic formula. So it's all kind of starting to blend together in our minds maybe. So I want to make sure that you still see all the things that we're talking about. And that's kind of what this week's about, is just keeping us together. So let's think about it. 3 minus 7. These are like terms. Hopefully you know that 3 minus 7 produces a negative number. I minus 6. So I know that looks like plus 6, but you have to take into account that this minus means you're subtracting every time. 1 minus 6, negative 5i. Okay? So once you try number 3, it's adding though. So be careful that you understand that you're adding. Let's kind of try to make sure you guys can, follow along at home. 3 times 5, 15. 3 times 2i is 6i. Okay, I want you to complete that problem. Keep going. And then I want you to remember that I squared is what value? What value is that? If you don't know, come to tutoring. Start coming to tutoring. If you don't know, you're probably not watching this video, honestly, from what I can tell about this class. But those that are watching the video, I bet you knew that was -1. So there's more. You need to do the next 2 steps. But this one's going to have this in it, and it's going to change the value. So your answer should still have a plus bi. It should be a number and then some type of imaginary value with it. So let's look at number 4. So this value right here, if I was just thinking about the square root of 25, I'd be quick to say that that's 5. But because it's negative, remember what makes things a square root negative? Like, how do we get around that? We got to say that that is a complex number by notating that that is an I. Now this 3, it's butted up against it. And that's not 35. That's 3 times whatever value comes out. So 3 times 5, 15. Plus 4, are those like terms? No. So you can't put those together. So if I wanted to flip the order, you could. That's okay too for that A plus BI effect. That's how you'd see a multiple choice answer. But they really are the same thing. Okay? Cool. So we talked a little bit about solving quadratics. So 2 of these, they're really supposed to be done the same way. And hopefully I'm going to try to use some highlighting to really show you how I know when do you factor versus square rooting, or when do you use quadratic formula versus square rooting. Okay? So I want you to notice that with this problem, like number 7, x is in 2 places. Okay? This means you have to use quadratic formula unless it's factorable. Okay? And we'll talk about that. This one similarly has x in 2 different places. So if you want to do those 2 problems, you could either use the quadratic formula, which does any problem. It'll solve any problem. Okay? But if you wanted to factor, you'd have to know if it's factorable or not. Okay? So to kind of get that idea going with you a little bit, let's talk about this one. Is there anything that multiplies to be that -10 and the 3 that's in the middle? Is there anything that would add to be that? Now, if you have no idea what I'm talking about, this is not going to help that much. But if you do know what I'm talking about, hopefully that jump starts your brain. Come see me. Factoring is its own world. If you didn't master that in Algebra 1, it's not going to be 10-minute mastering. You're going to have to spend some time practicing that. There's a lot of different types. So we have a factor set up of x and x. And if you've thought about this problem for a moment, what multiplies to be 10? Either 10 and 1 or 5 times 2. But we got to get -10. One of them's negative. And you also got to get them to add to be 3. So 5 times 2 is 10. But where should the negative be so that I get 3? -5 plus 2? Or is it 5 minus 2? Yeah, that's what we want. So x plus 5 and x minus 2 equals 0. Okay? So I'm going to scroll down for just a second just to give myself a little bit more room. Because you're solving by factoring, hopefully you're starting to understand that there's like this extra step. Okay? When I subtract 5 from both sides, I get x equals -5, and on the other side, you're adding to get positive 2. Okay? So that one is factorable. You could have used quadratic formula on it, but man, once you can factor, it saves you a lot of time. You don't have to use this crazy formula. Okay? So if you know how to factor this one, and I'm not saying it is possible to factor it, you just have to kind of get in there and look. But I would probably recommend that you try the quadratic formula for this, where A is 2, B is -3, and C is -11. Okay? So give that a shot. So want to jump back to the blue stars for a minute, and the other way that you could solve is using square rooting. Now, you have to develop an eye for how to see a problem and understand what tool to use. And this is true at any job. I don't care what job you're on. If you're on a construction site, each part of that job requires a different tool, and it takes time to develop that tool. Same thing with me making music. When I'm in the studio and there's something I want to happen, it's taken a long, long time for me to understand what that thing is that I have to do to make that sound be that way. So it just takes practice, honestly. So when we are looking at this one, you could factor this. But to be honest, I see that I could just add 16 over, and x squared is by itself. Now, if you noticed in 5 and 8, x squared is the only variable in it. Like with 6, x is in 2 separate places. They're both x, but one's squared and one's not. That's quadratic and linear, by the way. Those aren't like terms. That's why we need a formula like the quadratic formula, because that's a very difficult problem to solve. But when you only have x in one place, then that allows you to kind of old school solve it, if you will. But you must remember that it's got to be plus or minus. Okay? When you lose that plus or minus, you're literally losing half of the answer. So make sure that you do that. Okay? Similarly here, if you were to start by subtracting, okay, you get a negative, divide by 3, and you get 16 again, but this time as a negative. So very similarly to this, you're going to solve using square roots, but the only difference between these two problems is the I aspect. I makes it possible to do this imaginary answer. So it's still plus or minus 4, but we got to dictate that there was an I a part of that to really know that, hey, this is really more of an imaginary answer. Okay? All right, so evaluate using the discriminant. The discriminant is just this value. It's a part of the formula in the quadratic formula, but you don't do the square root. Now, I almost messed up today with a few of you, and I really apologize about that. I try to be perfect every day. It's just not possible. This should come out to be either positive, negative, or exactly 0. So there's 3 cases. If it comes out to be positive, then you have 2 real solutions. Okay? If it comes out to be negative, you have 2 imaginary solutions. And if it's 0, well, then you're only going to get 1 real solution. Okay? So remember, this formula, all it does is tell me how many there are. It doesn't tell me what the solution is. That's what the quadratic formula does. Okay? But for this one, we just need to figure out what part of that formula would be and just kind of talk about what it means in terms of how many answers we should look for. All right, so let's do one together. This is your A is 1, B is 5, C is 6. Okay? So let's see, B squared minus 4 times 1 times 6. Well, 5 squared is 25. 4 times 1 is 4, and 4 times 6 makes 24. So I got 1. So when they say evaluate the discriminant, there it is. The discriminant is 1. Well, because that's a positive answer, okay, positive answer, that means you're getting 2 real solutions. Okay? Try that on these other 3. We'll go over it in class. Again, email me if you have any trouble. All right? All right, so let's talk a little bit about the multiple choice. And I know some of y'all did these first few. So I'm going to jump down, and I'm going to save myself some time tomorrow so that I don't have to talk about number 7. Okay, number 7. Actually, you know what? We'll come back. We'll do 7 in class tomorrow because I think that would be a lot better. Let's talk about 6 real quick since we just talked about the discriminant. The discriminant is calculating just b squared minus 4ac. Okay? So when I'm looking for the answer here, you got to think, okay, what is b, what is a, and what is c? And does this come out to be which of these numbers? So we have b. What's b? Hopefully you're looking. And you know that this is A, B, and C. So really it's 28 squared minus 4. 4 is part of the discriminant. Okay, so some of y'all were kind of playing with that a little bit. That's part of it. It's locked in. But then A is that 4 that we see in the front. And then C is our 49. Okay? So let's see what we got. Someone can't put batteries in the calculator correctly. No class for that. All right, so we're doing 28 squared minus 4 times 4 times 49. Okay, just to give you a moment. Let's see if I can get it lined up with the, yeah, almost. That's what I'm typing in. Okay, let's see what that gives me. What'd you get? 0. This is h, and that's because b squared minus 4ac is exactly 0. Now it doesn't ask, but I hope you're asking yourself, well, what does that mean about how many solutions there are? How many solutions would this have? If we were to solve that, how many? Well, let's look back at what we were talking about a minute ago. If there are 0, if 0 comes out of the discriminant, that means there's only one real solution. And because I'm a baller, I'm going to show you what that solution is, and hopefully you're going to be amazed. And this way, I can talk about factoring as we wrap this video up. As I'm looking at this, and I'm wanting to really flex factoring for a moment, I'm locking in on the fact that this number and this number are what we call perfect squares. Perfect square of 4, square root of 4 is 2. And the square root of 49 is 7. Okay? So, see how close these are? And everything is positive. And so I'm thinking, well, I bet everything in here is positive. Okay? Now, I did that pretty quick. And honestly, even though I have a math degree, I would probably stop and make sure, like, is that right? Well, the only way I know if that's right is if I multiply them together. There's my 4x squared right there. 2x times 2x, 4x squared. All right, but then there's a 14x, and then there's a 14x, and guess what? That's 28. 7 times 7, 49, so this is correct. I've factored this correctly, okay? Now, remember, the discriminant only tells you how many solutions there are based on if it's positive, negative, or 0. So they were just asking, like, what is that discriminant value? That's 0. But I'm taking it further. I'm saying, okay, that means there's only one solution. So if I was to find that solution, I could plug it into the quadratic formula, or because it's factorable, and I factored it, and they're the same, then I can just set 2x plus 7 equal to 0 and solve for it by subtracting 7 and dividing by 2. And because that's the same for both of these, then there's only one solution, and that's what the whole point of getting 0 meant in the discriminant. All right, so I'll see you guys tomorrow. Peace.